Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. The AWS Certified Cloud Practitioner exam, currently referred to as CLF-C02, validates foundational, high-level understanding of AWS cloud, services, and terminology. In this video, we will be exploring 10 sample questions for this exam. The goal of this exercise is to review each question before exploring and eliminating incorrect answers, resulting in the correct answer being revealed. This is an essential technique for mastering AWS exam questions. Let's get started. A company wants to receive a notification when a specific AWS cost threshold is reached. Which AWS services or tools can the company use to meet this requirement? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. Let's highlight the key intent. Receive a notification when a specific AWS cost threshold is reached. This immediately signals two things. First, we need a service that monitors costs. Second, it must trigger a notification when a condition is met. We are not being asked to analyze or optimize costs. The focus is detection and alerting based on cost limits. Option A, Amazon Simple Queue Service, Amazon SQS. SQS is a fully managed message queuing service that allows decoupled components to communicate asynchronously. However, SQS is not a monitoring or alerting tool. It does not monitor costs, nor does it trigger notifications based on billing thresholds. It could theoretically be used as a downstream target for a billing alert, but it cannot create or initiate those alerts. Incorrect, because it is not used for cost monitoring or billing alerts. Option C, Cost Explorer. Cost Explorer is a visualization tool that helps you analyze historical AWS spending and usage trends. While it's useful for understanding where money is going, it does not offer notification capabilities or thresholds to alert when spending crosses a defined line. You can view and forecast costs, but you won't be notified automatically. Incorrect, because it is great for visual reporting, but no alerting functionality. Option E, AWS Cost and Usage Report. This service provides detailed billing files, often at the line item level, and can be delivered to Amazon S3 for analysis. While it's valuable for auditing and deep financial reporting, it has no built-in real-time alerting or notification mechanism. You'd need to build a custom pipeline to parse the files and generate alerts, a heavy lift compared to the right tools. Incorrect, because it is informative but passive, no built-in alerting. Option B, AWS Budgets. This is one of the best tools for this use case. AWS Budgets lets you set custom cost and usage thresholds and will automatically send alerts via email or SNS when those thresholds are crossed. You can define budgets at a granular level by service, tag, or linked account and track both actual and forecasted usage. Option B is correct, because AWS Budgets is the purpose-built service for cost thresholds and notifications. Option D, Amazon CloudWatch. While CloudWatch is traditionally used for monitoring metrics, logs, and application performance, it can also be used for billing alerts when paired with CloudWatch metrics. AWS exposes total account billing as a CloudWatch metric, estimated charges, which you can set alarms on. For example, to trigger an alert when your monthly cost exceeds $1,000, option D is correct, because CloudWatch supports billing alarms using the AWS billing namespace. A user needs programmatic access to AWS resources through the AWS CLI or the AWS API. Which option will provide the user with the appropriate access? Let us identify and interpret key phrases in the question that will help with answering it. Programmatic access to AWS resources through the AWS CLI or the AWS API. That tells us we're not dealing with web-based console access, but access from code, scripts, or automation tools. So, we're looking for a mechanism that authenticates a user or application to make API calls to AWS services. Option A, Amazon Inspector. Amazon Inspector is a security assessment tool used to automatically scan AWS workloads for vulnerabilities, deviations from best practices, and potential exposures. It is not used for user access or authentication. It evaluates your environments, but doesn't help a user gain programmatic access to AWS resources. Incorrect, because it performs security assessments, irrelevant for user API access. Option C, SSH public keys. SSH keys are commonly used for logging into Linux EC2 instances via SSH. While critical for instance-level access, they have no role in authenticating users to the AWS CLI or API. You can't use an SSH key to access AWS services like S3, DynamoDB, or IAM via the API or CLI. Incorrect, because it's relevant for instance login, not AWS service access via API CLI. Option D. AWS Key Management Service KMS keys. KMS keys are used for encryption and decryption of data. For example, encrypting S3 objects, database entries, or secrets. While you might interact with KMS after gaining access to AWS, these keys are not used to authenticate or authorize users to the API or CLI. Incorrect, because it is used for encryption, not for user authentication. Option B. Access keys. This is the correct answer. Access keys are composed of two parts, an access key ID and a secret access key, and are used to authenticate programmatic requests made via the AWS CLI, SDKs, or APIs. When a user or application presents these credentials, AWS verifies their identity and permissions via IAM. Access keys are tied to an IAM user or role, and should be managed securely and rotated regularly. Option B is correct, because it is the standard method for enabling programmatic access to AWS resources. A company is building an application that needs to deliver images and videos globally with minimal latency. Which approach can the company use to accomplish this in a cost-effective manner? Let us identify and interpret key phrases in the question that will help with answering it. The phrasing draws attention to the need for global delivery and emphasizes two critical goals: minimal latency and cost-effectiveness. The mention of images and videos points to static content that could potentially be large in size and consumed by a wide audience from different geographic regions. This immediately suggests a need for a solution that is not only fast and efficient, but also scalable and economical, especially at a global level. Option B. Store the content on Amazon S3 and enable S3 cross-region replication. Amazon S3 is excellent for storing static content, and cross-region replication helps duplicate data across regions for durability and compliance. However, this approach doesn't inherently provide low-latency delivery to end users. You're still serving content directly from S3 endpoints, which means users far from the region will experience higher latency. Plus, replicating data increases storage costs and doesn't optimize delivery paths. Incorrect, because it is good for backup and redundancy, but not optimized for latency or cost-effective global delivery. Option C. Implement a VPN across multiple AWS regions. A VPN is used for secure, private communication between networks, not for content distribution. It adds latency and complexity and would not scale for serving large numbers of public users accessing images or videos globally. Incorrect, because VPNs are for private networking, not scalable public content delivery. Option D. Deliver the content through AWS Private Link. AWS Private Link allows secure, private access to AWS services over the AWS network. Great for internal service connectivity, but not designed for public content delivery. It doesn't reduce latency for global users or cache content. Incorrect, because it is ideal for internal microservices, not global content delivery. Option A. Deliver the content through Amazon CloudFront. Amazon CloudFront is AWS's global content delivery network, CDN, purpose-built to meet exactly this kind of need. CloudFront caches content at edge locations around the world, reducing latency by serving users from the location nearest to them. It offloads origin traffic, integrates natively with S3, supports HTTPS, and offers granular control over caching behavior and access. It's also cost-efficient, as it reduces both origin reads and long-distance data transfer. For delivering static assets like images and videos to a global audience, quickly and affordably. CloudFront. CloudFront is the clear and correct choice. Option A is correct, because CloudFront is purpose-built for low latency, scalable, and cost-effective global content delivery. An e-commerce company has migrated its IT infrastructure from an on-premises data center to the AWS cloud. Which cost is the company's direct responsibility? Let us identify and interpret key phrases in the question that will help with answering it. In this scenario, we're looking at a company that has completed a migration from an on-premises data center to the AWS cloud. This transition shifts the responsibility model dramatically. AWS takes care of those foundational layers as part of its managed services. What the company still controls and is therefore responsible for, are aspects at the software and configuration level. That includes the applications it runs, how those applications are licensed, and how data is secured at the logical level. Option B. Cost of the hardware infrastructure on AWS. Once infrastructure is migrated to AWS, the company no longer bears the capital expense of purchasing or maintaining servers, storage devices, or networking equipment. Instead, it uses AWS's infrastructure in a pay-as-you-go model, with AWS managing the actual hardware. The company pays for service usage, not the underlying physical equipment itself. Incorrect, because the cost of AWS managed infrastructure is abstracted into service fees, not borne directly by the customer. Option C, cost of power for the AWS servers. Powering and cooling the data centers is a utility cost entirely managed by AWS. These operational details are invisible to the customer, and the company is never billed for energy consumption specifically. That burden is part of AWS's responsibility to keep its facilities running efficiently. Incorrect, because power costs for AWS servers are included in AWS's operational scope, not the customer's. Option D, cost of physical security for the AWS data center. Physical security, including surveillance, controlled access, and environmental monitoring, is handled solely by AWS. These measures are part of AWS's compliance and infrastructure duties and are not exposed to or charged directly to customers. Incorrect, because physical security is an AWS obligation and not a customer expense. Option A, cost of application software licenses. Even after moving to the cloud, the company is responsible for its application software stack. That includes the licensing for databases, third-party applications, or any middleware they install and use on AWS infrastructure. Whether the software is commercial or open source, AWS does not manage or pay for these licenses unless the company is specifically purchasing managed software through AWS Marketplace or services that bundle licenses. Since this is entirely within the customer's control, the cost of application software licenses remains their direct responsibility, even in a cloud-native environment. Option A is correct, because it is the one area where AWS customers retain full responsibility. To reduce costs, the company is planning to migrate a NoSQL database to AWS, which AWS service is fully managed and can automatically scale throughput capacity to meet database workload demands. Let us identify and interpret key phrases in the question that will help with answering it. In this scenario, the company is planning a cost-conscious migration of a NoSQL database to AWS. What they need is a fully managed database service, one that not only lifts the burden of operations but also automatically scales throughput capacity to match demand. The phrase reduce costs suggests they're looking for usage-based billing or dynamic resource allocation. Meanwhile, the mention of a NoSQL database narrows our focus to non-relational systems, while the emphasis on fully managed and auto-scaling leads us towards serverless or infrastructure-abstracted options within AWS. Option A, Amazon Redshift. Redshift is optimized for data warehousing and OLAP workloads. It is a relational columnar store, ideal for large-scale analytical queries, not operational NoSQL databases. It doesn't auto-scale throughput in the way required by real-time or transactional workloads and is not a NoSQL solution. Incorrect, because Redshift is a SQL-based analytics engine, not a NoSQL database with auto-scaling throughput. Option B, Amazon Aurora. Aurora is a high-performance relational database compatible with MySQL and PostgreSQL. Though Aurora Serverless offers compute auto-scaling, it still uses a structured relational model and doesn't align with NoSQL architectures. Its compute scaling is not equivalent to the granular throughput auto-scaling the question targets. Incorrect, because Aurora is a managed relational solution with limited auto-scaling that does not fit a NoSQL use case. Option D, Amazon RDS. Amazon RDS supports traditional relational databases and provides managed services for engines like MySQL, Oracle, and SQL Server. While it does support manual and some automatic scaling operations, it's not a NoSQL service and doesn't offer the kind of workload-driven throughput scaling required for cost efficiency at high variation. Incorrect, because RDS offers SQL-only support and lacks the NoSQL model and automatic throughput scaling. Option C, Amazon DynamoDB. Amazon DynamoDB is AWS's flagship NoSQL database service. It's fully managed, supports key value and document data models, and excels at handling high-throughput workloads. What makes DynamoDB especially relevant here is its ability to automatically scale throughput capacity. With on-demand mode, capacity adjusts instantly to accommodate traffic without manual tuning. Alternatively, auto-scaling dynamically adjusts provision throughput based on utilization patterns. Both features align with cost-saving goals by ensuring the company only pays for what it uses, no more, no less. Option C is correct because DynamoDB is the only fully managed NoSQL database with automatic throughput scaling, making it the best fit for the company's needs. A company is running and managing its own Docker environment on Amazon EC2 instances. The company wants an alternative to help manage cluster size, scheduling, and environment maintenance. Which AWS service meets these requirements? Let us identify and interpret key phrases in the question that will help with answering it. The scenario describes a company currently operating a self-managed Docker environment on Amazon EC2 instances. This setup implies that the company is responsible for tasks like managing cluster size, scheduling containers, and handling environment maintenance, all of which add operational overhead. The phrases help manage cluster size, scheduling, and environment maintenance point us directly toward a serverless container management solution that abstracts infrastructure responsibilities and dynamically manages compute resources. Option A, AWS Lambda. While AWS Lambda is a serverless compute service, it's not designed for managing Docker-based container clusters at scale. Though it supports container image packaging, it doesn't offer scheduling across a cluster or manage container orchestration features. Lambda is more suitable for short-lived, event-driven workloads, not for replacing a full Docker environment requiring scheduled task execution and resource management. Incorrect, because Lambda is for serverless functions, not full Docker orchestration or cluster management. Option B, Amazon RDS. Amazon RDS is a managed database service, completely unrelated to container orchestration or Docker environments. It doesn't schedule tasks, manage compute clusters, or run container workloads of any kind. This option addresses data storage and management, but offers no relevance to the container ecosystem described. Incorrect, because RDS is a managed database solution, unrelated to container or Docker workload management. Option D, Amazon Athena. Amazon Athena is an interactive query service that allows users to analyze data in Amazon S3 using standard SQL. It's designed for analytics, not for running containers or orchestrating Docker workloads. There's no concept of cluster size, scheduling, or environment management in Athena's operational model. Incorrect, because Athena is a query service for data in S3, not a compute or container management solution. Option C, AWS Fargate. AWS Fargate is a serverless compute engine specifically built to run containers without having to manage the underlying EC2 infrastructure. It integrates with both Amazon ECS and Amazon EKS and eliminates the need to provision, scale, or manage clusters. Fargate automatically handles cluster sizing, task scheduling, and environment maintenance. It perfectly aligns with the company's desire to reduce operational complexity while still supporting Docker workloads. Option C is correct because Fargate is the serverless container service that addresses all concerns, cluster management, scheduling, and maintenance, while maintaining Docker compatibility. Which tasks are customer responsibilities according to the AWS shared responsibility model? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. In this scenario, we are being asked to identify which responsibilities fall on the customer, according to the AWS shared responsibility model. This model clearly divides the security and compliance obligations between AWS and the customer. The phrasing, customer responsibilities, is key. We need to look for tasks where the customer has control and authority over configuration, data, or operational decisions within the cloud environment. Option C. Determine which availability zones to use for Amazon S3 buckets. Amazon S3 is a regional service, meaning its data is automatically stored across multiple availability zones in a region. Customers don't manually pick specific AZs for S3 buckets. This behavior is abstracted away from customers by AWS. Incorrect, because customers cannot choose availability zones for S3 buckets. AWS handles this distribution automatically. Option D. Patch or upgrade Amazon DynamoDB. Amazon DynamoDB is a fully managed NoSQL database. AWS is responsible for all aspects of its infrastructure, including patching, scaling, and maintaining its underlying systems. The customer simply configures tables and indexes, but not the operational management. Incorrect, because AWS is responsible for patching and maintenance of DynamoDB. Customers do not manage the infrastructure. Option E. Select Amazon EC2 instances to run AWS Lambda on VLAN. Lambda is a serverless compute service. Customers do not manage or select EC2 instances to run Lambda functions. The infrastructure is completely abstracted, and AWS automatically provisions and manages the compute layer. Incorrect, because with Lambda, AWS handles the compute environment. Customers do not choose EC2 instances. Option A. Configure the AWS provided security group firewall POR. Security groups act as virtual firewalls for Amazon EC2 instances and other supported services. While AWS provides the infrastructure and the mechanism, it is the customer's responsibility to configure the rules, what traffic to allow or deny, by port, protocol, and source. Option A is correct because customers are responsible for configuring security group rules that define traffic flow into and out of their instances. Option B, classify company assets in the AWS cloud. The responsibility to identify, label, and classify data, such as marking something as sensitive, confidential, or public, rests solely with the customer. AWS does not determine or enforce data classification. It only provides the tools to help protect it. Option B is correct, because customers must classify and protect their own data within the AWS cloud. Which AWS service or feature can be used to create a private connection between an on-premises workload and an AWS cloud workload? Let us identify and interpret key phrases in the question that will help with answering it. This question focuses on how to create a private connection between on-premises workloads and AWS cloud workloads. The emphasis here is on two environments, an on-premises data center and the AWS cloud, and a desire to link them through a private connection, not a public internet-based one. The phrase private connection is the key signal. We're looking for a networking service that bypasses the internet entirely to provide low-latency, secure, and reliable connectivity. Option A, Amazon Route 53. Amazon Route 53 is a domain name system DNS web service. It helps route end-user requests to internet-based resources and can direct traffic using routing policies, but it does not establish private network connections. It simply translates domain names into IP addresses and provides traffic management at the DNS layer. Incorrect, because Route 53 manages DNS routing, not private physical or network-level connections. Option B, Amazon Mastery. Amazon Mastery is a data security and privacy service that uses machine learning to discover, classify, and protect sensitive data in AWS, particularly within Amazon S3. It has no networking function and cannot establish or manage private connections. Incorrect, because Mastery is for data classification and security, not networking or connectivity. Option D, AWS Private Link. AWS Private Link is used to privately access services hosted on AWS over the AWS network. It does not directly connect an on-premises environment to the AWS cloud. Instead, it's typically used for accessing AWS services or VPC endpoints from within AWS or through a VPN or Direct Connect gateway when extending to on-prem. While it plays a role in private access within AWS, it's not the direct method for connecting to an on-premises workload. Incorrect in this context, because Private Link enables private access within AWS, but not a direct private link from on-premises to AWS. Option C, AWS Direct Connect. AWS Direct Connect is the ideal solution here. It provides a dedicated private network connection from an on-premises data center or colocation environment to AWS. This service offers high bandwidth, low latency, and consistent network performance, which is especially valuable for hybrid cloud architectures or latency-sensitive workloads. Because it bypasses the public internet, it enhances security and performance. It is purpose-built for exactly this kind of use case. Option C is correct because AWS Direct Connect is the service for creating a private, dedicated link between on-premises infrastructure and AWS cloud workloads. A company wants to provide managed Windows virtual desktops and applications to its remote employees over secure network connections. Which AWS services can the company use to meet these requirements? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. In this scenario, a company wants to deliver managed Windows virtual desktops and applications to remote employees, and it must be done over secure network connections. These three phrases, managed Windows virtual desktops, applications, and secure remote delivery, collectively point toward desktop as a service, DaaS, and application streaming solutions designed for distributed workforces. The focus is clearly not on building infrastructure from scratch, but rather using fully managed services that reduce operational overhead and provide secure, scalable access. Option A, Amazon Connect. Amazon Connect is a cloud-based contact center service designed for customer service use cases. While it enables remote agents to connect and serve customers over voice and chat channels, it is not a desktop or application streaming service and does not provide Windows virtual desktops. Incorrect, because Amazon Connect supports call center functionality, not virtual desktops or Windows app delivery. Option D, AWS Site-to-Site VPN. AWS Site-to-Site VPN provides secure connectivity between an on-premises network and AWS, typically used to extend a corporate data center into the cloud. However, it is just a connectivity layer. It does not offer any virtual desktop infrastructure or application delivery capabilities. Incorrect, because this is a networking service for secure tunnels, not a solution for desktop or application access. Option E, Amazon Elastic Container Service, Amazon ECS. Amazon ECS is a container orchestration service used to run Docker containers at scale. While ECS is great for deploying microservices or back-end systems, it's not suitable for delivering Windows desktops or GUI-based applications to end users. Incorrect, because ECS is meant for containerized app hosting, not end-user desktops or app streaming. Option B, Amazon AppStream 2.0. Amazon AppStream 2.0 is a fully managed application streaming service. It enables the secure delivery of desktop applications from AWS to any device running a web browser. This service is ideal when a company wants to allow users to access specific applications, like Microsoft Office or custom Windows-based tools, without deploying full desktops. Option B is correct, because AppStream 2.0 is designed for securely streaming Windows applications to remote users. Option C, Amazon Workspaces. Amazon Workspaces is AWS's desktop as a service, DaaS offering. It provides managed, secure, and persistent virtual desktops, including Windows, to end users. This service is perfect for remote employees who need a full desktop environment that they can access from anywhere. It supports integration with Active Directory, encryption, and a scalable deployment model. Option B is correct, because Workspaces provides secure, managed virtual desktops, ideal for remote workforces. What is a customer responsibility when using AWS Lambda according to the AWS Shared Responsibility Model? Let us identify and interpret key phrases in the question that will help with answering it. In this question, the focus is on identifying what responsibility a customer holds when using AWS Lambda within the context of the AWS Shared Responsibility Model. The key phrase here is customer responsibility when using AWS Lambda. Since Lambda is a serverless compute service, AWS takes care of the underlying servers, runtime environment, patching, and scaling. What remains squarely in the customer's hands is the business logic, the code, and its behavior. So we're looking for the answer that reflects what customers must directly manage in the serverless paradigm. Option B, confirming that the hardware is working in the data center. Ensuring the health of physical infrastructure is AWS's job. Customers have no access to the physical hardware, and AWS abstracts all infrastructure concerns away in Lambda. Whether it's disk failures, server health, or power availability, AWS handles all of that as part of its cloud responsibilities. Incorrect, because physical hardware and data center integrity fall under AWS's scope, not the customer's. Option C, patching the operating system. This is another responsibility that AWS absorbs when you use AWS Lambda. One of the key benefits of serverless is that you don't have to patch or maintain the OS or the runtime environment. AWS ensures the platform is secure and up to date so developers can focus solely on their logic. Incorrect, because operating system patching is managed entirely by AWS in Lambda. Option D, shutting down Lambda functions when they are no longer in use. Lambda is designed to be event-driven and ephemeral. You don't need to start or stop instances. AWS handles the life cycle of Lambda invocations. When the function is not being triggered, it's effectively off and not consuming resources. Incorrect, because customers don't need to manually shut down Lambda functions. AWS manages function execution. Option A, managing the code within the Lambda function. This is precisely the customer's responsibility. You write, maintain, and secure the code you deploy to Lambda. That includes managing dependencies, avoiding vulnerabilities in your logic, and ensuring proper behavior under various input conditions. The function's correctness, security at the code level, and operational logic are all customer-owned concerns in the shared model. Option A is correct because customers are responsible for authoring, updating, and maintaining the code that runs inside Lambda functions. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.